welcome back. This is our third and final video for the day, and it's all about the kite. How many of you here have experienced flying a kite when they were just a kid? I think most of the boys did. So let's get to know kite and its different properties on the next slides. As you all know, based on our lesson last week, kite is a quadrilateral with two distinct pairs of adjacent congruent sides. And this time, let's have our figure, and we have here quadrilateral kite, LOVE. Okay, so what do we mean by the word two distinct pairs of adjacent congruent sides? In this case, when we say adjacent, they have a common point. And with that, we can say that adjacent congruent sides here are segment LO and segment LE, and they are congruent. Another pair of adjacent congruent sides are segment VO and VE, and they are also congruent. And based on the tick mark, as you have observed, if they have the same number of tick marks, then they are congruent. Okay, let us now proceed with the different properties of kite. The first property is that the diagonals of a kite are perpendicular. Okay, and when we say perpendicular, they form a right angle, and when these diagonals meet, they measure their intersection forms a 90-degree angle or a right angle. That is why we have placed there an L-shaped figure, so that it indicates that the angle formed is a 90-degree angle or a right angle. And with that, we can simply say that segment LV is perpendicular to segment EO. That inverted T between segment LV and EO is what we call the symbol for perpendicular. Okay. Next property is that exactly one pair of opposite angles of a kite is congruent. Okay. So let's have our figure. Which of these angles are congruent? Opposite angles of a, because there is only one pair of opposite angles that is congruent. And with this case, let's mark it with an arc. Angle LEV and angle LOV are the opposite angles that are congruent. Okay, and with that, we can say that angle ELO and angle OVE are not congruent. Okay, they are of different measures. That is why different number of arcs are placed in them to indicate that they do not have the same measurement. Okay, next, if angle LEV is equals to 105, what is the value of LOV? So as practice, you can label your figure to fully understand it. If LEV is 105 degrees and it is congruent to LOV, therefore the measurement of angle LOV is equal to 105 degrees as well. That is what we meant by property number 2 of kite. Next, exactly one diagonal of a kite bisect a pair of opposite angle. Okay, only one diagonal bisect a pair of opposite angle, meaning when that diagonal intersected those pair of opposite angles, that angle was divided equally into two parts. Again, in this case, segment LV bisect angle ELO and angle EVO. Therefore, angle OLV and angle ELV are congruent, hence with the same number of arcs rather. And angles EVL and angle OVL are also congruent, hence same number of arcs in their angles. Okay? If angle ELV measures 24 degrees, let's have this. Let's label. If this one is 24 degrees, what is the measure of OLV? The measurement of OLV is also 24 degrees because they are congruent. So this one is 24 degrees as well. How about the measurement of angle ELO? The measurement of angle ELO, this whole angle, makes up ELV and OLV. Therefore, the measurement of angle ELO is 48 degrees. 24 plus 24 is equals to 48 degrees. Next example, same, still on property number 3. If EVO is 60 degrees, okay, this one here, label that. This angle measures 60 degrees. What is the measurement of angle EVL, this one? Marked with a yellow arc. Okay, since the whole angle measures 60, both EVL and OVL measures 30 degrees. Okay, just divide 60 into 2 and you'll be able to get the measurement of angles EVL and OVL. And next, property of a kite. Last property, the area of a kite is half the product of the length of its diagonal. Okay. So, if LV is 12 centimeters and EO is 6 centimeters, what is the area of a kite? Based on the definition or based on property number 4, the area of a kite is equal to half. Half means 1/2. The product of the length of its diagonals. Okay, our diagonals here are LV and EO. Half the product means multiply. Multiply the diagonals, then divide it by 2. Okay? If you do not have the figure yet and you want to familiarize yourself with the formula for kite is this. Another way to write the formula without the figure is that the area of a kite is equal to the product of the two diagonals divided by 2. These two formulas are just the same, but the one on the right is just if you do not have yet the figure. This one on the left side is based on the figure. So let us now substitute using the first formula. So the area is 12, the LV is 12 and EO is 6 divided by 2. Okay, 6 divided by 2 is 3 and 12 times 3 is 36. So therefore, the area of quadrilateral kite here is 36 centimeter square. The unit of measure for area is indicated with a square symbol. Another one. The area of a kite love is 135 centimeters square. And OE, which is one of the diagonals, is equal to 9 centimeters. How long is LV? So the missing is one of the diagonals and the given is the area and one of the diagonals. You can still use the same formula for the area of kite. Area of kite is equal to the product of the two diagonals, which is OE and LV divided by 2. Now let's substitute the given. The area of kite, the area is given by 135 and OE is 9. We do not know LV because we are looking for its value, then divided by 2. Next step here is to cross multiply. 135 is over 1. So 1 times 9 LV is 9 LV equals. Let's put a segment so that you know that they are together. 135 times 2 is 270. Then divide both sides by 9. Segment LV now is equal to 30 centimeters. That is the answer to the problem that we are looking for. Okay? Easy. Very easy. I know. You can do this on your own. Okay? Before we end our lesson for kite, let's have a short quiz. Let's just identify the following or fill in the blank. Segment GI is congruent to, yes, you are right, segment GT based on the tick marks. Segment TR is congruent to segment IR, okay, or RI. Segment GF is perpendicular to segment IT. This is based on the first property that the diagonals of a kite forms are perpendicular. Angle GIT is congruent to angle GTF, and this is based on property number 2 that only one pair of opposite angles of an isosceles trapezoid are congruent. And angle IFG is congruent to angle TFG. Okay, now this is based on theorem number 3 that only one diagonal bisect opposite angles. Okay, number 6. If TG is 6, how long is GI? Since they are congruent, GI is also 6 units. If IF is 10.5, then how long is TF? This is also 10.5 because they are adjacent congruent sides. Okay. Next, number 8, angle IGR is 32. How about IGT? Okay, this is 32. Now, how long? What is the measure of IGT? Okay, all you have to do is to multiply it by 2 or 32 plus 32, which make it 64 degrees. And lastly, we have angle TFI. TFI, this one here, which measures 40 degrees. What is the measurement now of TFG, this one? All you have to do is to divide 40 by 2 and you'll have 20 degrees. Okay, that's how you solve or identify the measurements of angles and sides of a kite. It's easy, right? So I hope you'll be able to apply all your learnings today in your tasks for this week. Okay, thank you all again for watching this video. I hope you'll be able to do your task and submit it on time. Goodbye again. See you next time.